Okay, we'll get started. I have already sent out a notice for students who are missing. Today we will continue to work on the algorithm, the second chapter of the algorithms on sorting and searching algorithms. And this one originally was a linear algorithms. And then last week we talked about the study of algorithms. So we look into the measurement of time, and we also look into the growth rate and memory growth rate and time growth rate. And we also analyze the different programs' efficiency. Okay, basically we go through the different type of the program, branch, selection, iteration, all kind of the program structure to analyze its efficiency. And then we also talk about the big O notation and the big summation, the summation and pi for the big sigma notation. So we talk about that. That's a preparation for study of the algorithm. Now we move on into the chapter 20 and 21. These are two chapters of the basic algorithm at the AP level. And then these two are very important. And besides that, I want you to learn the study of the algorithm. So from this point on, you will continue to move on to study the data structure and the algorithm. So whenever you study an algorithm, you need to look into its efficiency and its basic operations, how it works and how fast it works. And then knowing how to apply those algorithms to different domains. And also you need to memorize the algorithm, and later you need to be able to repeat them. Okay. So next week, okay, I will announce it next week. We will test you on the memorization of the algorithms. So for example, I'll tell you how to write a selection sort. And you need to reply me, write it down within 7 minutes. Okay, so you need to memorize the algorithm for those algorithms that we covered today. So the next week we'll test it, okay? Is that okay?
Yeah.
Hear me?
Yeah.
Yeah.
Kirsten, hear me?
Yeah.
So Kirsten, I asked you why we need to memorize those algorithms.
Yeah. Because otherwise you have to experiment and like start from scratch every time you need to use them, and they're very common.
Yes. So this one, we just tell you how to study the algorithm. So to study the algorithm, first, you need to know how you work. Second, you need to analyze how fast you work. Third, you need to memorize the code or memorize something. So today we will introduce you the way to memorize the code. We call it pictorial memorization. You need to remember the pictures. Okay. Now let's get started for this different sorting and searching algorithm. So we will go into the linear search and binary search first. And then we'll talk about this include algorithm and prime number algorithm. And then we will go into the sorting. Okay, so again, we have many algorithms we need to work at. So first one is linear search. Linear search is pretty simple. You just go through the numbers and do searching. Okay, I think we covered this one in chapter 7 or 6 or 9, okay? Something like that. We actually covered the linear search before. So one thing that I want to say is that if you use the function of index of itself is a linear search, okay? It's trying to find the index of some numbers. So that by itself is a linear search, okay? Here we'll quickly go into there. Okay, so this is 1 to 10. And we want to do searching. This one is pretty simple, but I just want to go over it again to make sure that you knowing how to study algorithm. So first one, you need to remember the code. So you go through every single one. That's actually very simple. If you not found, return -1. Okay, this one pretty simple. For linear search. So last time we talked about it, the best time for this algorithm is 1. The first one you find. Worst case for this algorithm is actually order of n. Average case is order of half n. Okay, so this one, the complexity is pretty simple to analyze. So we won't waste too much time on this one. Let's just finish it. Okay, well, I don't want to waste too much time, so just give you one example. I can test many times, but right here, we don't want to waste time. So this simple linear algorithm, we actually just run it. So the first one is linear search, okay? That is easy. Now I'm going to copy this one for the binary search. So linear search is order n algorithm. Next one, let's have the binary search. So we have the same data, and then we want to sort on, we want to actually search on. But the one problem is that before you do searching, you must have the data sorted. So right here, you will do, okay, you sort on A first. So this one is merge sort. And it is n log n algorithm. Okay, it's an order of n log n algorithm. So you pay this much cost before you do searching. So if this sorting is included, binary search is slower than the linear search. But if your sorting is not counted, then binary search is faster. So right here, let me change it to search. So search is binary search. Okay. So we will do binary search. So binary search, you need to remember the algorithm of binary search that first you need to sort the data. Okay. Second, after you got the data, you set your low to the lowest number, high to the highest index number. You start to work on that. And then you find a middle point to compare with the key. If it's bigger, key is bigger, then you will search the right side. If it is smaller, you search the left side. Okay, so by search to the right side or left side, you move your low to the mid +1, then that's searching the right side. You move the high to the low mid -1, that's actually searching the left side. Okay, and then the algorithm will stop whenever your low is greater than high. Then you have a crossover. Equals still okay. Equals still okay. Equal means there's only 1 element. So this one, you need to remember how the algorithm work. Here, I just memorize. First, you get the high and low, and then while low is less than or equal to high. So this one, while no crossover. Well, no crossover, you do the following things. Once you get out of the algorithm, your guaranteed low will be greater than the high. So this one has crossover. And then in this case, you will return -1. Right here, you can also use a -1 minus low. Remember the way that we call it I number. I number equals -1 minus low. If you actually try to find the insertion location of the low. So when you get out this I number, you use the -1 minus I, you will get your low number, and that is your insertion location where you should insert the data. Okay. So some of you on the chapter 17 homework, you just run the Java program to get the data. I mark you wrong, okay? Because you never explain to me why you get that number. You just run the program. That's actually cheating. Okay, that actually is cheating. We need you to completely understand the sorting algorithm by the array.sort. Okay. Okay, anyway, when you get into here, you have the midpoint equals half of the low plus half divided by 2. And then you compare the midpoint with the key. Okay. So if your midpoint is bigger than the key is on the left side, then your high will be equal to your mid -1. You move your high to 1 below your midpoint. So you will search the left side. Okay, right here you have 3-way equal, greater, or less than. So one of these will happen. So this right here, you don't need to do if anymore. The last one, you don't need to do if anymore. So this one, actually, this is the binary search algorithm. Okay, you need to remember how to remember this algorithm. So basically, what is low number, what is high number, what is midpoint, and something like that. Okay, that's just wrong. Something wrong. Oh, here, high, I set it to be wrong. It should be 8 length -1. I set the wrong initial value. Okay, so this is binary search. Next one, if we want to do recursive, let's call it searching. So before we write the main program, I'll write this helper function for the binary recursive searching. Okay. So when it is crossover, you return some value. The crossover part is if your low is greater than your high. That's the crossover condition. Then you will return -1 minus low. That's your termination condition. If not, then your low is less than equal to high. Then you go into this portion. You go into this portion. So you go into those portion, you should have integer mid equal to half of the low plus high divided by 2. And then you will check which one you will do. So if A is I'm sorry. So right here, I combine the recursive algorithm as well. Okay, if the mid value equal to P, then you return your mid value. That's already found the answer. Otherwise, if your mid value is greater than your key, means your key is on the left side, then you will continue to do searching on the left side. So you should return the searching of your A with the key. Then your left searching your left side, so your low is still your low, your high should be your mid -1. Okay, and then otherwise you don't. It is a three-way test. So the last one you do not need to use else. You directly do searching of A P and then mid +1 and high. This one means that your key is bigger. Okay, your key is bigger, you look at it here. So now this one is your helper function, and after you finish your helper function, you continue to work on your original function for the recursive binary search. Okay, right here you do not have the low and high. That's original, you only have this. And then this one should return searching of A and P and the 0 and the data length -1. So that's your main function and helper function for binary searching if you do recursive. This too should get the same result. For those of you are late today, let me announce one more time. Today we are covering different sorting and searching algorithms. And next week we will test on the memorization of these different algorithms. I'll give you 7 minutes for each algorithm, and I'll tell you which algorithm you need to memorize. And you need to write a text file. I don't text Java file. You just use your editor to type the text into a text file. And I'll look at your text file whether it's correct or not. Okay, I don't take the Java because I don't want you to use a BlueJ or any compiler to check its grammar. Then that's not memorization. Is that okay? Hear me?
Yeah.
Harrison, hear me?
Yeah.
Okay. Make sure you actually remember it. Every algorithm that we cover today, no matter it's linear searching, binary searching, recursive binary searching, with a helper, we all will test you. Which problem, I don't know. I may test you 2 to 3 algorithms next week. Each one of them, I'll give you 7 minutes. If you cannot solve it by 7 minutes, that means that you never remember it. So it's okay. That just means that you don't remember it. So you have to remember it. I may make a little bit of a change, but you have to remember. You need to remember both the regular version and the recursive version. Okay, that's a must. Because you are going to the exam, you are also going to the competition. If you don't remember this, it is not acceptable. Okay, that's good for you. Okay, that's the binary search part. We cover the binary search, binary linear search, binary recursive search. So we are a little bit more than what they actually cover here. Okay. Any questions so far?
Wait, Dr. Chang.
Yes.
The test is gonna be next week during class, right?
Yeah.
Okay.
The purpose of that test is making sure you memorize it. So you need to practice before it. Okay. You can also memorize it and have your parent to check for your result. Okay, that's actually okay. We just want you to memorize it. No matter what, I just want to force you to study the algorithm and memorize it and make sure that you can remember it. That's all we want to know. Okay. I don't care about your score. Actually, why should I care about your score? I don't care. Where you go to college, I even don't care. But I do want to know that you really remember that. Okay. That's a key point. So again, we teach you the binary search and the binary linear search. So the searching algorithm that you use in array class, array S class, it is using binary search. So when you do searching in arrays that search, it is using the so-called binary search. And it is using binary search, so the return result would give you the -1 minus low. That's why when you see there is a -2 in the answer of the number 17, it do give you this number. Okay, it do give you this number. So that's very important. Okay, next one, we are going to go into the sorting. Before we go to the include algorithm, finding prime number, that's actually not an important part. Let's go to the sorting algorithm. Okay, for the sorting, one thing that I would let you know is that AP exam. The AP exam, they will have 4 FRQ problem. Problem 1 is on the method and control structure. So this one tells you if then else, while loop, for loop. Okay. Second one would have you to write a class. So you will have a one class design. Third one is array list, but this next year you will drop the array, only keep the array list. So array list is more important than array now. FRQ number 4 would be 2D array. So in a way, you still need to know array, but they only test on 2D array now. So this 4 problem would be control structure, class, array list, and 2D array. So whatever sorting algorithm will give you this year, I will use an array list instead of array. Okay. So now let's go into the sorting of the different algorithm. Before we do sorting, let's have a class. This class, let's use our good friend. This class is called point. So I will use array list of point to do sorting. So a data point may have X and Y. So let's do it. Okay, well, right here you want to use this one that you may want to use private. That's actually okay. Okay, so I finished two string function and its point function. Now, what I want to talk about is that if you put the data into the array list, then you may have the index of function, and then index of function need to have the equals function to work. So you must remember to implement your equals function. If you don't have an equals function, they will compare the ages only. And another thing you need to remember is that this one that work with the array list index of function must be using object. Must use an object reference type. Okay, so object, you may got an object, but it may not be the point type. So you can say if not what? Your other is actually is instance of point. So this one is the operator. So if other is not an instance of point, then it's not comparable. So you actually will return false. So by this one, you includes all of the non-point object. Okay. Other than that, you get into here and you will do this. You will do conversion of the point from object type to point type. So you convert it to point type. Okay, so other change to lot. Okay, so this one, you check the data type and you also compare the contents. If they are the same, then we consider these two objects are the same point. Is that okay so far?
Yeah.
Next
Yeah.
one, we want to do sorting, so we need to have a compare to function. To implement a compare to function, you must have a function that's called, you must implement comparable of the point type. Okay. You must implement comparable. Let's implement comparable. Okay. No, the point type is okay. So comparable of point type, and then you need to implement a function. This one has some problem because it does not have a compare to function. So you need to have a compare to function, and the compare to function different from equals. Equals use object, but compare to function, it will not return the Boolean value, it will return integer. And then you need to do compare to. And then this type is point type. Okay, so compare another type, another point called dot points. So this point and that point, so this actually compare these 2 points. Okay. So right here, because you do sorting, but sometimes you want to do sorting on X, sometimes you do want to do sorting on Y. So here we may have a static variable. Let's use Boolean, okay, Boolean. So mod X set it to be true, then you will compare X, okay? So here if mod X, it do the following thing. Okay, the mod X, you compare X, and mod Y, you copy this part out. you compare the Y value. Okay. So basically, if you are actually you are more the X, then you will compare the X value. Default is X value part, you compare only X. If not, you will compare Y. So you can do sorting both on X and Y. Okay, let's actually do it. Okay. So before we go into the different sorting, let's use the array.sort. Okay, so this one, let's use array sort. First, we need to create an array of the points. Let's put like 10 points, 8 points. Okay, let's assume that we actually finished the 8 points of the array. And we want to test it by the sorting. Okay, so before sorting, we print it once, and then we do sorting. This one must be static. And then we need to do sorting, so we do arrays plus sort. And then we print it. And then we may want to do descending order, so let's do arrays plus sort. So here you may need to use a collections but reverse order. Let me check, okay? Reverse order. and then you print it again. So this one is using the sorting algorithm in the arrays class, okay? So sometimes if you are in the competition, you need a sorting and you want to use merge sort. You don't have time to write it, you just directly call this array sort. But you must make sure that your data already been sorted. I'm sorry. There's no need for sorting. Okay. So right now we are doing the XMOOC sorting. So it should just sorting based on the X order. So based on the X order, you have -4, -3, -2, -1, 1, 3, 5, 7. Okay, that's actually correct. Down counting, you go from 7, 5, 3, 1, -1, -2, -3, -4. That's okay. So that's reverse order. So when you need to do reverse order, here remember that you need to use collection that reverse orders function. Putting the comparator here for the sorting algorithm. Okay, that's one parameter. Any questions so far?
Yeah.
Next one, you want to do sorting the Y part. So you use this variable to be false. Then you do sorting again 2 times. So this one you would set to the Y mode and then sorting on Y. Okay, after you sort it on Y, let's see here, -4, -2, -1, 1, 2, 3, 4, 5. That's correct. From big to small, 5, 4, 3, 2, 1, -1, -2, -4. That's correct. Any questions so far?
Yeah, I have a question.
So here I show you 2 things. Number one, you have a class of point and make it comparable with point. And we will implement one function that's called comparative function, and it can be comparing just the X or comparing the Y. Here, we do not use the compare X then Y algorithm. Okay, we do not use that because we just want to sorting on X or sorting on Y. Okay, we do not have a tiebreaker of when X equals. When S equals, we just return 0. We don't actually have a tiebreaker to break it. Sometimes the problem want you to have a tiebreaker, but not this one. Okay. But anyway, we implement a version that actually allow you to sort on X and both sort on X and sort on Y. So we do have this array sort. So first algorithm is okay. We actually finished the array sort. Now I'm going to create another one. This one I'm going to start the insertion sort.
Dr. Ch
Yes?
Yeah.
What happened?
I have a question.
Yeah, go ahead.
Is the test next week also gonna be on like the sorting, or is it just gonna be the binary, like recursive, like linear search?
Everything I covered today.
Okay.
Actually, I emphasized this twice already. Number one, don't be late, okay? Don't be late for the class. You make me repeat several times, and you also ask a question that I don't think that's actually appropriate. You care too much about the test. Bottom line is I want you to study, not that I want you to go to the test. Harrison, you got it?
Yeah.
You care too much about the homework and test so far. Every kind of question you ask is only on the homework. You don't care whether you know or not. You need to go beyond it, okay? At this moment, you show me that you are actually just want to match the performance. You are not the kind of student that you want to go beyond. Go beyond means that you need to do more than what I teach you. If you cannot go beyond, you doesn't belong to the elite university, say MIT or Stanford. You doesn't belong to those classes of a student. If you want to become a student in the top elite university, you need to be going beyond, way more beyond what your teacher teach you. Hear me?
Yeah.
How about Kingston? You hear me?
Yeah.
If you want to go beyond you want to go to the top elite university, you need to go beyond what your teacher have teaching. You need to be showing that you are a person that can break through any kind of bottleneck. You are a person that can be on top of everyone. Okay? If you just want to stay in the class returning homework, sorry, you are not the kind of person that should deserve a seat at MIT. You are not, because you are just a mediocre student. Why should MIT admit a mediocre student? Kirsten, right?
Yeah.
How about Jiang, you hear me?
Yeah.
MIT don't take mediocre student. Normal person, AP 12 AP class, that's just normal person. MIT or Stanford or Berkeley or CMU, the top 4 CS school, they want someone who can invent and change the world, not someone sitting there to listen to the lectures and then repeat the homework only. Those students still far beyond being able to make the top university, okay? You have to change your mind. If you just keep doing the mediocre thing, you never go there. Okay? I'm trying my best to help you, but you have to help yourself as well. So far, many students still just like second tier, third tier student only, okay? You have to change yourself. Next one, we'll do sorting on the P array, point array, and sorting on X or sorting on Y, it doesn't matter. We use the compare to function. So here we will do public, okay, static void, let's use void. And then this one, let's actually do sorting. Let's do insertion sort. But this insertion sort, I will work on in array list of point. I don't work on array, I work on array list of point. So I do sorting on this array list that you give me, okay? First thing, I want to make sure we are sorting on X mode. So let's do point that mode X equals true, okay? I know its default value is true, but I want to just make sure that it will be sorting on X. Now, next one, I'm going to do insertion sort. So this one will be a destructive sorting. The array list data will be changed. The order will be changed. So here you return it or don't return it, it doesn't matter, okay? It doesn't matter. So now you need to put an array list over there. So you will put the P list over here. But before that, you need to create a P list. So let's create a P list. Loading the array to the array list. So okay. So here we actually loading the array list into the array list P list, and then we do sorting. After that, we are going to print it. So let's print it. Okay, this one is p-list, so there is no need for using the array list dot sort or dot toString. Okay, there's no. Now we want to do insertion sort. Now let's go into the algorithm for insertion sort. So for insertion sort, you need to keep inserting the data into the inserted array. Okay, let's assume that we have let's actually try to give you an example, short example. So right here, let's assume that we have a data of 3, 5, 1, 4, 2. Okay. So now the first one is a sorted area. So 3 is sorted. Now the first one to be insert location. To be insert location starting from 1. Okay. So starting from 1, then actually if 5 is bigger than 3, so you keep 5 over here. You actually keep 5 over here. You don't move 3 over. You put the 3 over here, and then you make 3 and 5 sorted. Next one, you will actually, to be inserted location, will be moved to 1. And then you compare with 5. 5 is bigger, so 5 move to this location. And 3 is bigger, you move to this location. And then after that, you actually run out the number, so your 1 will be put into here. So then 1, 3, 5 are sorted. Next one, you actually to be sorted location is 4. Then you will actually compare 5 is bigger, so move to here. 3 less than 4, so 4 put to here. So you will have 1, 3, 4, 5. Next one to be inserted location is 2. 5 is bigger, so you move to here. 4 is bigger, so you move to here, move 1 location. 3 is bigger, so you move 1 location. Then 2 is bigger than 1, so 2 put into here, 1 remain here. So it become 1, 2, 3, 4, 5. So it is sorted after that, okay? So your to be sorted location is from here to here, from 1 to the end of the array. Your compare location starting from the and let's assume that you are comparing here. You're actually starting from here. If you are to be inserted location here, it's starting from the 1 less than you until you actually run out of data. Okay. If it's bigger, you just move to the right. Okay, that's the algorithm we will use. Now let's look at the code. Okay, so right here, initially the data is 2954816. So first to be inserted location is 9. So 9 bigger than 2, so 9 no change. So 2, 9 considered to be sorted. We use the red color. The next one to be inserted location is 5. So 9 bigger, so move 9 to 5. 2 smaller, so put 5 at the 9th original location. So to become 295. Next one to be inserted location is 4. 9 bigger, 5 bigger, to keep sorting, and then 4 put into the 5th location. 2 is smaller, so 2 won't move. Next one is 8. 8 is 9 is bigger, so move 9, so we put it over here. Okay, keep doing that, you will have the data sorted. Okay, so let's see. So each run of it, you have to remember how it changed, okay? When you do AP, they'll test you each run of them, how you actually, how the data on each run of the process will be. So let's actually look at here. So here you go into the insertion location, the outer loop is the to be insert location. So integer I equals 1, I less than p dot list dot size, and then I increase. So these are the outer loop. Outer loop is, so outer loop is to be inserted location. Okay, outer loop is to be inserted location. So you will start to compare from j. So integer j will be equal to I minus 1. You come in from the next one. Okay. So while j greater equal to 0, while j still have the data, and p list dot get, here you have the I, okay, get I compared to p list dot get j. Okay, so p list dot get I is the i's point. You will compare with the j's point. Okay, if these two I is greater, then you will continue to move the data. So what you will do is you will do this. You will do, okay, here first you need to back up your data. So your point data will be equal to p list that get I. Okay, back up your I location. Then your p list that get j. Okay, I'm sorry. Your j's data I'm sorry, your j plus 1 data should be p list that get j. You will move your j location to the right. Okay, move your j location to the right. And then your j will decrease. Okay, so you keep doing that. So let's assume that you actually go out of the loop because your j become negative. So your j, when you get out of there, it may be negative. So when you get out, your j is over deducted by 1. So right here, you have to do j increased. And then p list that set your j will be using the data to set it. Then this one will do your insertion sort. Let's try, okay? Let's try. So this one sorting on x1 minus 1, 5. Wait, this one after sorting? No, something's wrong. P list. After your ji compare. No, here is actually, it's not compare I, it should be I, your j compare with j plus 1. No, let me see. It's your, no, this one, no, I'm sorry. This one should be your data. No, I'm sorry. This one is the opposite. This one's data. So it's p list, but it say when your left-hand side value is bigger than the data, then you will move. Okay. So my algorithm is a little bit wrong. Some error there. Let's see. Okay, this one correct. So X is a solid based on our order now. Okay. Now let's test the Y mode. So this one, let me change it to be false. Original sorted by X is okay. We don't need to reload it again. We just need to sort it using the Y mode. So Y mode -4, -2, -1, 1, 2, 3, 4, 5. That's actually correct. Okay. Any questions so far? So outer loop is to be inserted location. Every time you find the location that you want to insert, the data you want to insert. So the first one, if you have 3, 5, 1, 4, 2, this one is sorted. This is the first one to be sorted. So you use this one. So if the data is 5, data you back up is the to be inserted locations data. And then you would say if it's bigger, you move to the right. If it's bigger, you move to the right. Move to the right until it is smaller. Okay, until it is smaller than small equal to, then you will stop. And then the J will be overcompensated, so you need to increase J by 1 and then put the data into the empty location. Is that okay so far?
Yeah.
You have to remember the method. And next week, we may not test you on array list. We may test you on integer. We may test you on double. Okay, but you still need to work out the sorting algorithm. Okay, so don't just memorize the code. It may not be enough. Right here, we use array list and point class as example. But we may not do it in the exam, okay, in the test. You need to really go beyond, okay? We want you to really learn it. Any questions so far?
No.
So this chapter is algorithm after algorithm, okay? So next one, we have sorting, selection, sort. So insertion sort, okay, let's go back to insertion sort. Before we do succession sort, we haven't covered the efficiency. So insertion sort, if your original data is 1, 2, 3, 4, 5, you already sort it. Then this one is very efficient. No swap, no swap, no swap, no swap, no swap. So totally no swap. So this one is order of 1. It's actually constant time. It's very, very fast. Okay. If you have a reverse order 5, 4, 3, 2, 1, then it's the worst case for insertion sort. And it will be order of n squared. Is that okay?
Yeah.
These two, when we do study algorithm, okay, again, number one, you need to remember the method. Number two, you need to be able to analyze the complexity. Third, you need to be able to rewrite them. Okay, these are any one of these when you do practicing for the algorithms and in your user code competition, you need to keep doing that. So this is your business now. If you want to go into CS, this is your business. You need to do this for your life. Okay, every day just keep practicing different algorithms. That's computer science. Okay, you got to remember them. You got to pick up them. Okay. Okay, so here we go into the selection. So we still do array list. I'm going to change it a little bit. So the testing part, we are not going to change anything. The algorithm will change. So the whole for loop, I'm going to delete it. And then I'm going to change the name of the sorting to selection sort. Okay, so that's the only thing that I will change. So same sorting setup, we should get the same result. Now we are going to go over the selection sort. We need to implement selection sort, okay? Now let's look at selection sort. So what is selection sort? So insertion sort is that you do find each insertion location, which one to be inserted, and insert into the sorted area. Okay, that's the idea of insertion sort. Now let's look at the selection sort. So the first few chapter we talk about language. Now we don't no longer talk about language. Now we don't talk about algorithm. So when we touch the algorithm, you have to be perfect on your language. Otherwise, you still struggle with, should I use this to string function? Should I do the content or whatever? Then you are out. Okay, then you are out. You cannot continue. So next one, we'll do selection sort. So selection sort is different from insertion sort. So the first number is this one. This is to be inserted, to be selected, to be sorted region. So first one, you sort this one, and then this one is to be swap location. So 2 is to be swap location. You look for the smallest number to swap with it. So right now number 1, so you swap these 2. So first round you swap 1 and 2. Next round to be swap location is this one. And then you will swap 2 again. So 2 and 9 swap. 2 is the smallest. So every time you find the smallest from to be swap locations. So third one to be swap location is 5. You look at the smallest one is 4, so you swap with 4. Next one is 5. 5 already smallest, so no swap. And then next one is 8. 8 swap with smallest, that's 6. So we swap these 2. Next one to be swapped is 9. You swap with 8. 8 is smaller, so you swap. So that is the basic selection sort. So selection sort is a swap-based sorting. Okay, it's a swap-based sorting. Now let's look at it. So outer loop is the to be swap location. Okay, so if you only have one number, so let's assume the previous one, 1, 2, 3, 4, 5, 6. This 1, 2, 3, 4, 5 already be swapped. The next one is 6. There's only one 6 that you don't need to swap. So the last one don't need to swap. So here you have the -1. So to be swap location starting from 0 up to size -1. Up to size -2. Size -1 won't be swapped. Okay, so here you would have integer I, integer, you already had an integer I. Now you want to find the minimum, okay, minimum. So let's do always minimum. So the minimum will be equal to the P list. Okay, your current location is the minimum, okay. And then you will do this for integer j equals I plus 1. And then j less than P list the size j increase. So you go into every single one and you do comparison to see which one is the smallest one. So if you check this one, the outer loop is 0 to n minus 1. Okay, inner loop is from I plus 1 up to n. So if you check this number I and j, actually is the same as the upper triangle that we talk about for K-graph. Okay, it's exactly the same. But that's another story. You can study the algorithm. Okay, the algorithm is actually the same. So now you had a minimum, and then if you were this that get J that compared to minimum is less than 0, is smaller, right? Smaller than your okay. Here you should also have the index. Okay, here let's use I. Okay, then your minimum index would be equal to J. Okay, and then your minimum would be equal to P list dot get J. Okay. You select a new minimum if the current point is smaller than the minimum. Out of that, you get out of here, then you will do swap because you find the minimum and your to be swap location is I. These two numbers you need to swap. So if I not equal to, if there is a swap need for swap. If the to be swap location and the minimum location are not the same, sometimes it will be the same if no one smaller than it. Then you don't need to swap. So if that is need to be swapped, then your temp will be equal P list that get I, and then P list that set I will be equal P list that get index P list that set index. You will set temporary value. Okay, so this one is swapping your to be swap locations. That's it. This one will finish your selection sort. That's wrong it, okay? I think it's okay. Any questions so far? Sorting X and sorting Y both work. Any questions so far?
No.
This one, you need to remember the outer loop is to be swapped location, which number or which point need to be swapped. And you will find the rest of the array, who is the smaller than that. If there's a smaller than 1, you pick the smallest one as the index. This index is smallest the index, mean is the smallest value, and then you will swap index with the I value. Okay, so this is swap-based algorithm for selection sort. Okay, next, so this one, it is a, as I told you, it actually is the same index structure as the K-graph. So this one is n times n minus 1 divided by 2 algorithm. So it's the order of n squared. And base case, worst case, the same because it's always doing the same number of comparison. Is that okay? Hello?
Yeah.
So in base case, insertion sort is better than selection sort. Base case, insertion sort is better than selection sort because base case, if the data already been sorted, the selection sort take more time because it's the order of n squared. Okay, but worst case, then they may be the same or selection sort is a little bit better. Okay. So these are the comparison for these two. Next one will cover the bubble sort. So these are three linear sorting algorithms that we covered: selection sort, bubble sort, insertion sort. So I'm going to copy the whole thing over again. Okay, now you do this one's bubble sort. So let's change the name of the sorting called bubble sort. And the content we will change. So let's delete it. Okay, sorting setup will be the same. Okay, bubble sort. Bubble sort is probably the easiest one to do sorting. Okay. Bubble sort probably is the easiest one to do sorting. And in fact, I learned this one in the summer of my high school, before the college. I learned the bubble sort the first time I learned computer programming. Okay, in the summer of my high school senior year. And then I learned the bubble sort. At that time, computer is not so competitive right now. Okay. And we do teach bubble sort. So bubble sort is the easiest one that can do sorting. Idea is easier, but the efficiency is not good. It's also an order of n square algorithm. Okay, bubble sort. So bubble sort, the main idea is, let's assume you have the 2954A41. So one is the bottom of the ocean. Okay, bottom of the ocean. So you keep swapping, then the heavier one sink to the bottom of the ocean. So the first round you do swap these and swap these and swap these and swap these and swap these. So first one you swap 2 and 9. 9 is bigger, so keep 9 here. And then you swap 5 and 9. 9 is bigger, so keep 9 to be here. And then you compare 4 and 9. 9 is bigger, so keep swapping. And 8 and 9. 9 is bigger, so you swap. 1 and 9. 9 is bigger, so you swap. So the first round, after the first round, your 9 sink to the bottom of the ocean. Okay, second round, this 9 already been sorted. So your bottom of the ocean set to 1. So you do comparison. So the heaviest one, 8, sink to the bottom of the second bottom of the ocean. So this 8, 9 considered to be sorted. Next one, you sink 5. And then 5, 9, 8, 9 is sorted. Then next one, you sink 4. This is sorted. Next one, you sink this one. Is that okay so far?
Yeah.
Okay. So the outer loop is the heaviest location. Okay, it's the heaviest location. So the outer loop is for integer j equals p reached plus psi minus 1. Okay, and j greater than 0, j decrease. Okay, you actually do every time your J decrease. So this one, outer loop, J is the heaviest location, the bottom of the ocean. So starting from the very last one, okay, now you keep swapping up to J. Okay, so you do let's use I, okay, let's don't use J. Let's outer loop, let's keep using I. So I is the heaviest location. Now you use J. J will start from 0 and then J less than I. So J will be one smaller than I. Okay. And then J will increase. So every time you do swap. So if P is the get J compared to, if it's out of order, P is the get J plus 1, if it is out of order, so this one is greater than 0. That means it's out of order. J is bigger than J plus 1, so you will sync your J. In this case, you need to do swap. In this case, you need to do swap. So your point temp equals P list that get J P list that set J P list that get J plus 1 P list that set J plus 1. Okay. So this one apparently is also a swap-based algorithm, but that's it. This one is the simplest algorithm so far. So this one, just doing that, you will finish your bubble sort. Okay, that's it. You get the data, the same data. Okay. Now let's go back. So this one is the standard algorithm. If you actually just do it, but there's some problem. If you do have 1, 2, 3, 4, 5 already sorted, then you will continue to do the sorting. Okay, you continue to do the sorting. So now let's do this. Let's optimize this algorithm. Okay. So the outside, let's set a Boolean variable. Okay, this swap they actually okay. I'm going to optimize the algorithm. So you do this swap. Okay, and then you go into the loop and you set this swap to be false. Okay. I'm sorry, I put it into the wrong location. Should be here. Okay, if you actually need swap, then you go into here, need swap is false. But if you do swap, then your need swap is true. That means that you already saw the data, you still need swapping. But if the whole wrong, you do not need swap, then it will not need we will not need to continue to do swap. That means that you already sorted the algorithm. By doing this, you will speed up your algorithm. Okay, to speed up your algorithm. So these are 3 Boolean statements is optional, not the original Boolean command, not the original bubble sort. It's an enhanced version. You still get the same data. Okay. Any questions so far?
No.
Okay, so we finished insertion sort, selection sort, bubble sort. Next one, we are going to go over the merge sort. Okay, next one is going to the merge sort. So array.sort actually is using this merge sort algorithm. Okay, the Java's array.sort is using merge sort algorithm. Many of the standard algorithms in the C++ STL, they also use the merge sort. Okay, so you need to learn this merge sort. So this merge sort, the idea is you have a array list, you divide it into 2 parts, and then you further divide it into 2 parts. Keep doing that until you have only 1 element. Then this is split, keep splitting. And then you merge back. Once you want to merge back, you merge them according to their sequence. Okay, according to their sequence. According to who is smaller, go first. So 4 and 5 crossover, 1 and 8 crossover, 6 and 7 no crossover. So you actually sort it here. When you merge, you put that into place. Now after that, your 2 elements sorted, you merge these 2. So you have this 4, 5, and then 2, 9, and 4, 5. Okay, you do merge. So 2 and then 4 and then 5 and then 9. Okay. Any questions so far? So this one is a divide and conquer algorithm. You divide the array list into half. Every time keep dividing into half until you have only 1 element. Then you automatically return. Okay. And then you merge the 2 array lists together according to their order. And then by doing that, eventually you will do sorting. Okay. Now let's create a merge sort. So let's use the same thing. We use the same setup, okay? The only difference that merge sort has compared with the previous view sort is a merge sort is it is recursive. So right here, you actually do merge sort. So because it's recursive, right here, you need to return something. And then let's delete everything here. We don't need that. Let's actually delete everything inside, okay? And at this moment, let's just return new, okay? And here, I'm going to change this one to merge sort. Okay, now, before we do merge sort, we may need to have a function called merge. So we have two lists, A and B, we want to merge them together. And the new list will be C, so let's have array list of the point, let's call it C, okay. Now at the end, you will return this C array list. Now you want to merge the A and B together. So you have 2, 4, 7, 6 merges 1, 2, 8, 9. Okay. So that's when this is A, this is B. So the first one, you will put the 2 into there. I'm sorry, put the 1 into there. Let's put this one as a 3. Okay. So next one, you put 2 into there. And then you put 3 into there. And then you put 4 into there. I'm sorry, this 2 should be 6 and 7. The next one, you put 6 into there. And the next one, you put 7 into there. And this one, you put 8 into there. This one, you put 9 into there. So you always select the smaller one from the two list. Okay. So now you will need to have the integer p equal 0, integer q equal 0, while p less than data size and the q less than beta size. So while A and B both not running out of the array, then you will do the following. You will do if p dot get, I'm sorry, A dot get p dot compare to b dot get q is less than 0. So A compared with B is smaller, less than equal 0. Okay, equal also consider for A. Okay. Then we would take one data from A and then put it into C. So C dot get A dot get P plus plus. P move on to the next number. Okay. And C add one number from that number. Next one, if A dot else B is smaller, then the C dot add B dot get Q plus plus. Okay, so when you get out of here, it's either P greater or equal to A dot size, or Q greater than P dot size. One of these happen because one of the array run out of the data. Okay, so you put the rest of the other into the array list. So you do file A dot A size and C dot A P plus plus. If A not totally used. Same thing you would do for B. Okay, then you move everything in B into C as well. So only one of these will happen because only one of these actually not totally used. And previous one will use one of them because you do comparison and then try to get a smaller one. So this one will merge for the smaller one. Now you go into the merge function, merge sort. So when your merge sort gets started, the first statement you would do is you would check the size of your P list. So if the 0 or 1, you return itself, you will not continue to do splitting. So you return it right away. Okay, otherwise you will calculate your low and integer your high. Okay, you calculate your low and high, and you calculate your midpoint. Okay, this midpoint will be your middle on the left if it is even number. Okay, it will be your middle on the left, but it's in your left side. So let's assume we have three numbers. Let's assume that we have 3, 5, 4, 3, 5, 8. Index 0, 1, 2. So the middle one is this one. Okay, so we have 3, 5, 8, 9, 0 and 3. The divided half is this one. The middle one is this one. So you're dividing from here. Okay. So this one is your middle one. And you will use middle plus 1 for the new array. Okay. So let's do partition the array list into two halves. We have the middle number, and then we are going to participate the array list into two parts. Okay, so the first part, okay, we create a array list for the first part, and we also created for the second part. So it divided into two halves. Okay. Okay, you divide your list into two halves. Now you are going to copy the first from your P list. You copy from 0 up to mid. Okay, plus 1. Mid plus 1 not including. Okay, to the first half. So let's do this. For integer I equals 0, I less than mid plus 1, I equals. Okay, and then you will do first that add list that add I. Okay, then you will do second part. The rest of them. Okay, so you actually put half of the array list to first, put half of the array to the second. Then your first would do merge sort. Again, okay, recursively. Your second part, we also do recursive sorting. After that, you create an array list of the third one. And this third one will be equal to merge of your first one and the second. And that's it. You will return your third list. That's completed your merge sort. Okay, so what you need to do right now is actually THIRD. You need to understand the algorithm and be able to rewrite them, okay? Make sure you understand everything, including how to merge two arrays together, how to merge two arrays together, and then also design your merge sort. You have to go through and memorize the whole merge sort, divide it if it's an atom, if only one element, you return it right away. If not, you divide it into two halves, and then you sort the first half and sort the second half, and then merge them. Okay, that's it. That's a merge sort. Something's wrong. Okay, something's wrong. Something is wrong. We do not sort. Here we forget to return it. Okay, you actually don't get the return value. I forget to put a return value because the merge sort would have return value. Let's do it again. Okay. Okay, it's sorted. Any questions so far? Any questions so far?
No.
You have to practice before you know it, okay? This one I just go over the idea. So the idea is divide by two and merge, divide by two and merge, divide by two and merge. This is the merge sort. Now next one, we will have an extra topic. AP won't test it, but a lot of advanced competition will need it. That is the quick sort. We will cover the quick sort. Okay. Last year I don't cover the quick sort. So this quick sort has a pivot. So quick sort is very easy. You pick a number and then divide the data into small part and bigger part. And then you pick a number, divide it into small part and bigger part. Pick a number and then divide it into small part and bigger part, and then merge them together after your partition. So you pick the number, divide it into half, and then do sorting. Okay. So quick call is very easy. We'll directly write the code. So you pick a number and then divide it into two halves, and then do sorting. Okay. So let's keep the same one. Let's actually copy the whole thing over. Quick sort is also recursive code. It will also return an array list. Okay, this one is similar to merge sort. A merge sort, most of the performance is better than quick sort. Okay, so here let's call it. No, we don't have the merge anymore. Let's delete the merge part. Okay, here let's change it to quick sort. And the inside, let's delete it. I'm sorry, it's too slow. Okay, so here I change it to quick sort. So quick sort, the idea is you pick a number and then divide it into two halves and then merge them back. Okay. So first one is if your P list, the size is less than 2, no data or one data, you directly return it. So no longer need to be split and sort. No. Okay. Now, this one you actually get it. Next one, you set a point, that's point called pivot. So this pivot will be P list that get 0. Okay, so you have at least 1 point, at least 2 points. So you get your first point. Okay, and then you go over every point. So starting from the first one, down to P list the size. You go through every number, every point. Okay, you will create 2 array lists. One is called small. Okay. One is called large. Okay. So after you get these 2 done, whatever you want to do, eventually you have a array list or point. This one let's also call it third. Then your third would add all of your small. Then your third would add your pivot. That's the middle point, like the one you use for comparison. Then your third would add all of your large. And then eventually you will do return third. Okay? Now this part, okay. But before you add the small, your small will be quick sorted. Using your small one. Your large will be quick sorted by your large one. Okay, now you need to divide your data into big one and small one. Okay, so if E list but get I compare to pivot less than 0. This is smaller than small that add your P list that get I, okay. Otherwise, large that add P list that get I. Okay, so you divide it into 2 halves. One part, left side is smaller, right side is bigger. We use the pivot, the first one, as a comparator to split them into 2 halves. And then you sort on the left, sort on the right. And then after you sorted, you merge them back using add all, add all. And then after that, you actually get the result from the quick sort. Okay, and then it should work for the quick sort. Okay, is as good as it is. A quick sort is quick sort is almost like almost like the merge sort time, but you on the average case, merge sort is better than quick sort. But quick sort, the idea is easier. When you do coding, quick sort is easier to do coding, okay? Because you just compare the big one and small one. Is that okay? So far?
Yeah.
So today we introduce tons of algorithm using the array list. Okay, you got a lot of work to work on. Okay, you got a lot of work to work on. We are 9:46. I don't want to continue because if we continue, we can talk about the Euclid algorithm prime number. This take more time. That's number one. Number two, this two algorithm is not related to searching and sorting. So next time we will do the two lists as well. Okay, we talk over the algorithm, but today we may just finish up. Okay, we actually will do a little bit of the analysis of the algorithm. We finish this different algorithm, but first thing I will repeat the analysis for the binary search. Okay. Binary search is very important. So when you do binary search, if you do one comparison, you can search for one data because f of 1 equals 1. If you do two search, that means you search the middle one, bigger you search the right side, smaller you search the left side. So here the second search, so one search, two search. For those two search, you get three elements. You are searching for three elements. So you do three search. Then you check the middle one, that's one comparison. Then left side, two search. Two search is three elements. Right side, two search, that's three elements. So totally you have 2 times f of 2 plus 1. This one will be 7. Okay. So if you do fn, that will be 2 to the power n minus 1 plus minus 1. 2 to the power n minus 1. Okay, this one is the same as the Hanoi Tower. You need to remember that, okay? Because in the AP test, they will test you how many comparison needed or how many times needed to do binary search. Okay, that complexity you need to be able to analyze. So today we finish different algorithm. For you to do, you need to write them in array list format, and if possible, also try to change this data set to integer array, to do insertion show by integer array by yourself. We may test you on the array list, we may test you on the integer array. We don't know, okay, we don't know. But we will spend about 3 to 4 problems next week in class testing to make sure that you memorize them, okay? Everybody hear it?
Yeah.
Belinda, you hear it? Hello? Oh, Belinda, you cannot talk. It's okay. How about Harrison? You hear it?
Yeah.
How about Jen? You hear it?
Yeah.
I call in everybody. Just make sure you remember them. Okay. Don't tell me that this week that I don't remember. You never tell us to memorize. Okay. Actually, I told you. How about this? Can you remember it?
Yeah.
You not only need to practice the array list version, but also you need to try to change the data to integer array and then solve the integer array. Okay, here I give you the version of the array list because AP test now is only testing on array list. So I use that as an example, okay? But you need to memorize them. It's very important because a lot of advanced algorithm is developed based on these different sorting algorithms, okay? So if you cannot remember these, I don't think you can handle even tougher problems. For example, like merge sort is also a divide and conquer algorithm basis. And then quick sort is also a dynamic programming basis. Okay, so you have to remember that. Okay. Okay, that's it for today and wish you good luck and then work hard. Okay, good night and bye-bye.
Thank you.
Thank you.